Hello everyone, I am Sameer Verma and today we will be discussing different types of load on a structure. So as we know that a load can cause stress, displacement, deformation, on a structure, which results in structural problems, right? And it can even cause structural failure. So, to determine a load in a structure is very important. So, the structure should be designed in a way that it should be strong enough to bear any type of load. Strong enough to bear any type of load. So according to Indian Standard 875/1987 and American Standard Code ASCE 7, so it deals with various design loads of structures. So there can be different types of loads. One can be vertical loads and second is horizontal loads. Right? So first we will be discussing vertical loads. So under vertical loads, first is dead load. So what are dead loads? These loads are permanent loads which are carried to the structure throughout their lifespan. So these are the permanent loads. And it occurs mainly due to self weight of structure, fittings, fixed partitions, and fixed equipments, etc. So suppose to build a column we need steel, bars, concrete, shuttering, etc. Right? So how can we calculate or determine dead load on a structure? For instance, let us say this is a column. So let us make a column. This is the top view. Let us say this is elevation of a column. Fine. Let us say the height is 3 meters. .4 meters. Let us say this is also 0.4 meters. So this portion it is showing as 0.4 meter and 0.4 meter. Fine. So how to calculate the dead load? So dead load of column can be found by using the total volume of concrete, or there in this case it is column, that is 3 into 0.4 meters into 0.4 meters, which gives 0.48 meter cube, right? So the dead load of the column can be found out by volume into unit weight of concrete. It is 25 kilonewton per meter cube. This was meter cube. So it will be like 12 kilonewton. So second type of vertical load is live load. So now what are live loads? So as the name itself resembling that these type of load are real-time loads. Live loads are also called imposed or sudden loads. So live load can be weight of furniture, or maybe say people occupying the floor, etc. Fine. So how can we find the live load? So it is basically given in, live load is given in kilonewton per meter square. Fine. So like for floor in houses or hospitals, minimum load can be taken as, live load can be taken as 2 kilonewton per meter square. Likewise, for shops, restaurants, it can be taken as 4 kilonewton per meter square, and so on. Well, now the third type of load, vertical load, that we are discussing can be snow loads. Fine. So snow loads are considered only on the structure which receives snowfall during monsoon. So for snowfall during monsoon. So for the structures which receives snowfall during monsoons. So this is also a vertical load. So snow loads can you can find it is mentioned in IS 875 Part 4 1987 IS code. And snow load can be found using this formula, where S is design snow load. Mu is shape coefficient, and S0 is ground snow load. Right. So these are the three loads which we consider under vertical loads. Now we will discuss horizontal loads. Horizontal loads. So first type of load that we can consider in horizontal load is wind load. So it is considered wind load. It is considered in design if the height of the building is more than 15 meters. If height is more than 15 meters, right? So the wind loads are occur due to horizontal loads caused by the wind. So let us say if this is a house, so wind loads will be acting horizontally. So the structure should be strong enough to bear these loads. If the structure is not strong, then the building may blow away. Fine. Another type of horizontal load can be earthquake loads. So these type of loads causes movement of the foundation. Of structures, right? So these are internal forces. And these are because of ground movements. So three mutually perpendicular forces act on the structure during earthquake. Two are horizontal forces, and one vertical force, which is due to weight of structure. And the vertical force does not affect much during earthquake, whereas two opposite horizontal forces result in movement of the building during an earthquake. So earthquake loads we can take in we can consider example of Japan. So this country is prone to frequent earthquakes. So it is in a very severe earthquake zone in the world. And how can we compute these seismic forces? Seismic or earthquake forces which are acting on the structures. It can be done by two methods. One is response spectrum method. Another one is seismic coefficient method. So till now we have discussed there are two types of loads. One is vertical load, another is horizontal load. Under vertical load we have dead load, live load and snow loads. And under vertical loads we have wind loads and earthquake loads. And there are other types of loads also. And these types of load can affect the safety and serviceability of the structure. So there can be foundation movement, which is given in IS 1904. Next can be erection load, which is again given in IS 875 part 2. Now next is vibration and fatigue. Same way, soil and fluid pressures. It is also given in IS 875 part 5. So these are the loads which we have to consider for designing or to check the stability of any structure.